I'm right here, so just watch out.
The motor spun so fast that it spun itself apart, and the wheel fell, and it got in contact with something fell, and the wheel got in contact with the steel plate that it's mounted on, and it stopped turning.
Can you quickly point to me where the problems are?
The wheels treads, they keep sliding off when we drive. Let's see, on this robot, the mounting points were not exactly talked about very much, so we'll get to that. Let's see, the wheel. Yeah, the wheel right here, under here, it made contact. And then, yeah.
Alright, so we basically just started with this 80-20 layout with the square kind of design.
Yep.
And then we put a sheet of aluminum or metal on top of that. And we put these rails. And then next we put on the guard. And then after the guard we had the wheel placed so that the disc would fit tightly enough that it would have enough friction to spin and get out of here. And then after that we designed the upper one, which we cut out of metal and made it so it would fit out the front. So you would get it out the front, then you would shoot out the front, makes it a little bit easier. And we also added a piston below here, which catches the underside of the frisbee.
Can you give me a little closer look? I need to see.
Oh yeah.
Is it just this right here?
It's this guy right here. This piston here pushes out, and the frisbee on the edge of it will push it out and shoot it straight out of there.
Ah, very good. Can you point to it again?
That's right.
For the camera. Thank you very much.
Yep.
Okay.
And that's a key part of it because that gives a lot more momentum before it gets to that wheel, and it'll get it going right away.
Very good. Is there anything else you'd like to add for the benefit of people watching?
I guess keep up the hard work. Tried out a bunch of different designs. We started with no rails, and then we put on the rails and made a big difference, and along with the piston. So adjust the speeds and the angles and see how it goes.
Thank you, Kevin. See, you can do it. Come here.
Yeah.
Thanks, man.
Right now we're trying to discuss whether or not to do the long robot or the square one or the wide one, and that's all up in the air between which shooter needs which and which climber is necessary. So we'll be running some tests tonight to try to figure out what it's going to be. It's looking more like square, so it can incorporate both designs, but we'll get back to you on that.
Sounds good.
So currently we've been talking about major benefits and not so benefits with wide and long drivetrain. We've been talking about a lot about third level climbers and what will go wrong, that can go wrong about a third level climber is that a robot is pretty much out of the game, which is bad. But the benefits of getting a third level climber is just exponential, especially when we have so much more time to continue working on that.
Well, I was working on a lot of CAD until we had to have this discussion about strategies. And now my CAD just sort of sitting there and I'm waiting for a final design to CAD.
It's just a basic it's like saying I don't believe in those freaking like giant like full scale model drawings they made of Swerve.
I don't believe in
I do. I believe in full scale modeling.
You don't like going on adventures in jungles?
No, the internet.
What?
I don't like Safari. I don't like Firefox. I don't like internet.
I don't believe in you.
What is this chickenery?
I don't believe
What
in
is
you.
your chickenery?
I don't like Internet Explorer. I love Internet. Plain Internet's great. I don't like Internet.
Okay.
I don't like Firefox.
Chrome.
Chrome.
We're halfway
Chrome is where it's at.
Chrome
right there.
is where
Maybe you could devote some of your hatred to something more constructive.
I don't know.
All the Nick's are great models.
Party.
Can I actually get a decent picture of it? I gotta use a picture with the other one. Thank you.
Today we've been working on setting up the design for our code because we have a lot of sub-teams working on different classes for the programming. We have people working on drivetrain, people working on shooting, people working on climbing, and they need to all be able to interface their code, but they can't all be looking over each other's shoulders the entire time to see how they're implementing the different joysticks or controls. So this meeting we've spent the entire time working on an object model where we just have all the different classes laid out, and it shows what methods and everything each different class has, and which classes are subclasses of others. Like drivetrain, shooting, and climbing are all subclasses of the main robot class. And then we have joysticks, which are their own class that are like with controllers, and we have it so we can choose between Xbox or joysticks depending on which we want.
Let's go.
Let's go.
Just keep on doing this. Give me a face. Give me a face. That's a face. Thank you.
The entire diagram in the center is BT Robot, which is the main class that we have. This class will be filled with, this will be the operator control and autonomous, where it just says, while it's in autonomous, do this, while it's in the operator control, do this, and then those different methods will reference the other classes such as autonomous, and the arrows indicate that like BT joystick is owned by control board, which is owned by the main robot, and then autonomous is owned by BT robot, which is our main class. So the arrows just show which classes own what. Then, as you can see over towards the left, a couple of the boxes are getting filled with more than just the name of the class. And once we're done, all of them will have stuff in there, but those show what different motors or sensors we have and variables for each class, and which methods they have, which lets them show, like, it uses a drive method where it needs 2 joysticks input or something, so that people working on joysticks and people working on the drivetrain can work together.
So it seems like most of these boxes aren't filled yet, except for vision and drivetrain.
They'll just be filled up with the basics of what different methods it has and what variables it uses, what different sensors and motors will be used, so that we can program it without having to go and check with each group to see exactly how they're doing everything to make sure we interface correctly. And right now we just have the 2 filled in that are filled in because we need to fill the first one in as an example so everyone would understand what we're doing. And now we're going through as subgroups filling in the sections that we're working on. So by the end of the night or by Saturday, it should be a lot more filled in than it is right now. We'll continue to program the robot, and we'll use this to be able to make sure that everything is designed well, and we'll be able to interface what we need to interface, so the shooting, autonomous, and climbing can all access the vision to see, am I lined up for a target or to climb? And we'll just basically be using this for reference to make it simpler to program.
Okay, very good. Thank you very much, Tim.
Thank you.
I just want to ask everyone to smile and be like, smile?
Quick question for you.
Yeah.
We thought about using an actual camera.